Welcome to our first screener session on SIMUL8's new Developers Corner. Today I'd like to cover a typical example of a rotating weld table. Most automotive plants have several vehicle types traveling down the same lines using flexible tooling systems. One common flexible tooling system is a rotating weld table with unique faces. Each face may contain unique dimensional control and locating pins set up for a specific vehicle type. Most of the time, this rotation time can be contained within the overall cycle time of operation. But when an overcycle condition exists on the rotation, it can cause significant throughput losses. In this example, it takes 15 seconds for the table to rotate, and it can rotate in either direction. We have 4 unique vehicle types set up in a probability profile distribution being released in random order. Therefore, there will be a 15-second or 30-second delay depending upon the sequence, and all the other equipment is running at 60 jobs per hour. This model is collecting timestamps for each vehicle as it enters the load table with an internal SIMUL8 spreadsheet, which can be found under Spreadsheets. Here we can verify each overcycle as it enters the weld table. Within the spreadsheet, we have the vehicle identification number, the vehicle type, the time that it's ready to exit, the time that it actually loaded on the face, and therefore, when we subtract these two, the actual overcycle that existed. We can see that most of the overcycles are the 15 seconds. This is within minutes, so that's a quarter of a minute, so 15 seconds. But we can also see that some of them did require 2 rotations, so totaling up to the half-minute time. In this model, we can see the percent of time that the actual load spot is blocked. In this case, it's blocked nearly 20% of the time. It's waiting for the table to actually rotate into position before it can actually index over. We can see how that this can overall negatively impact our throughput. So this overcycle is creating a system that could potentially run near 60 jobs per hour, and it's running now at 48 jobs per hour. Of course, we're just looking at the system on the overall process of sequence and this overcycle, and no downtime has been entered into this. But it does really show the importance of analyzing potential overcycles with respect to sequencing. We can conduct a quick verification run by setting the distribution, the probability profile, to just one vehicle type, the vehicle type distributions, by simply going here and set it to just producing 100% of vehicle type 1. Let's go ahead and run that. So I hit OK. Rewind the model, and we'll go ahead and run it. We'll see now that we're just producing one vehicle type. The table obviously does no need to index. There should be no overcycle being produced. I'm going to go ahead and speed up this model all the way to the end. We'll just batch it out to the end. And we can verify that we are achieving our 60 jobs per hour. There's no overcycle occurring. So we can conduct several what-if analysis, differing our sequence. We can look at different, if we were to do batch builds or do some type of blocking effect of sending out consecutive vehicles, what impact that would have on reducing our overall overcycle that exists on the tables. So there can be a lot of what-if analysis and knowledge that can be gained by testing out different scenarios. And we can see how quickly we can do this. And that's why we at SIMUL8 believe that the software is powerful, flexible, and fast. So thank you for listening to today's session on our Developers Corner, and I look forward to our next session.